Welcome everyone. In this video, I'll go through a calculation involving water of crystallization. It's an A-level chemistry exam question. Details are in the description. Let's get started. Here's the first part of the question. A student heated a solid sample of Na2CO3.XH2O for 1 minute to remove the water and determine a value for X. The diagram shows the apparatus used. The table shows the results recorded. The mass of the empty evaporating basin is 24.35 grams. The mass of the evaporating basin and solid before heating is 25.47 grams. And the mass of the evaporating basin and solid after heating for 1 minute is 24.92 grams. Use the data to calculate a value for X in the formula Na2CO3.XH2O. Give your answer to 2 decimal places. The equation there shows what's happening when the substance is heated. Hydrated Na2CO3 is present in the evaporating basin before it is heated. The mass of the hydrated sodium carbonate can be found by difference. Subtract the mass of the empty evaporating basin from the mass of the basin and the hydrated solid to find the mass of the hydrated solid. This works out to be 1.12 grams. There is a flaw in this procedure that we will look at later. However, the intention is that heating the solid will evaporate or drive off all of the water of crystallization, leaving anhydrous sodium carbonate in the basin. From the equation, 1 mole of the hydrated solid contains X moles of water of crystallization. We can find the mass of the anhydrous solid by subtracting the mass of the empty basin from the mass of the basin and solid after heating. This works out to be 0.57 grams. The mass of water that is removed from the hydrated salts can be found by subtracting the mass of the anhydrous salts from the mass of the hydrated salts. This works out to be 0.55 grams. We can use the mass of water to work out the amount of water present in moles. Amount of substance is equal to mass divided by molar mass. I used lowercase g for mass as a reminder that this should be in grams. It also avoids any confusion with the letter M used for molar mass. Use the datasheet to work out the molar mass of water if you have to. The amount of water removed works out to be 0.030556 moles. The amount of anhydrous sodium carbonate present in the evaporating basin after heating can be found in a similar way. This works out to be 0.0053573 moles. The value of X is found by dividing the amount of water by the amount of anhydrous sodium carbonate. This works out to be 5.68. This must be given to 2 decimal places, and this part of the question is now complete. Here's the next part of the question. The correct value for X is 10. Suggest a reason for the difference between the experimental value for X and the correct value. Looking back over the procedure, the hydrated salt was heated for just 1 minute. It is likely that some of the water was not driven off during the heating. Here's the next part of the question. Suggest how the procedure could be improved using the same apparatus to give a more accurate value for X. Justify your answer. It would be good practice to heat until constant mass. This is a key phrase that you should try to remember. It means that you would heat the evaporating basin for a minute and then weigh it, then heat for a further minute and weigh again. Repeat this process until the mass is constant. This will ensure that all of the water is driven off. Thanks for watching. I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.